Hello, everybody. Hello, I say. There we go. After so many trips to Norway, it's nice to make it north of Oslo for once. So this is a very nice place. When I proposed this talk many months ago, I don't remember exactly when, it was just sort of off the top of my head. I want to talk about the evolution of JavaScript. And I didn't really think at the time about what I was saying or the implication of that word, evolution. In the United States, we still regularly debate evolution as it applies to life. And when I think of evolution, of course, we think about things like gene drift and random mutations and natural selection. And I thought maybe that really doesn't apply to a programming language. Or does it? JavaScript's always been a little bit different, hasn't it? We don't necessarily have gene drift, and we don't necessarily have random mutations, but what we do have is a JavaScript language that, first of all, maybe you know this story, that it was designed in roughly 10 days. How many people know that? Netscape hired Brendan Eich and said, please come and build a scripting language for our browser. We would like to make it interactive instead of just static text and images. And by the way, please have the language ready by the end of next week. There's a big marketing event we're going to have with Sun. They're introducing Java. We want to introduce JavaScript. They're not related at all, but we're going to make a big marketing move, and that's how JavaScript originated. And if you ever wondered why it has so many quirks and strange features, it's because it was put together pretty quickly. But it was standardized in 1993. That was version 1 of the ECMAScript specification. And then there was version 2, and then there was version 3, and things seemed to be progressing. And those original versions, by the way, really didn't move the language forward at all. They were tweaking some behaviors of the language, clearing up some things that weren't clear in the original specification. And then we got to ECMAScript version 5 in 2009. So what happened during that big gap? And then finally, in 2015, we had ECMAScript version 6, or ECMAScript version 2015, whichever one you want to call it. But that big gap, I think, is interesting. That big gap, I think, actually did allow JavaScript to evolve. There was a specifications committee working on improving the JavaScript language and adding features to it, but they fell apart because of political infighting. They couldn't decide actually what direction the language should go. And I think it was fortuitous. I think what happened between 1999 and 2009, all sorts of interesting things. There was the XML HTTP request object that was introduced by JavaScript, because if you do want to build an interactive web page, chances are you'll want to communicate over HTTP and pull back data. And it'll always be in XML, right? So we'll call it the XML HTTP request object. But other interesting things happen. Interesting things like jQuery that showed us, actually, it's not too bad to program in the browser as long as you have an API that behaves consistently. And then, of course, Node.js came around, and all of a sudden, JavaScript wasn't just in the browser. It was in this completely different environment where people were building web servers and flying quadcopters and writing JavaScript to do network routing and all sorts of interesting things. So by the time this most recent specification came around in 2015, there were all sorts of community standards and features and unofficial specifications that had evolved and come around more organically. So things like, how do we deal with modules in JavaScript? How do we write small components and stitch things together instead of going through a global window object? So I think the language has evolved. Now that version 4 specification, by the way, this code is from a blog post that I did in 2007. This is what the language was going to look like in version 4. So notice there's an interface keyword. Notice things like type annotations, access modifiers. What does this look like? Java, TypeScript. I'll take both of those answers. Things are a little bit different now. The JavaScript that came out in this latest specification, which is really the first substantial addition to the language in its history, really took a lot of inspiration from the rest of the ecology around it. So not just community standards that were driven by developers in the Node.js world, but also other languages that are popular, Python, Ruby, Lisp. even C#. You can read some of the wikis and the design notes of the JavaScript standards committee that were putting together the language, and they would mention these languages like C#. We want this feature from C# in JavaScript. That's why I say it's the old new JavaScript, because there's a lot of things that you see in the new language that you'll be familiar with if you've done programming in other languages. So I just briefly want to go through some of the features that I think are interesting and impact the way that we're going to be building applications in the browser in the coming years, and also take a look at one example framework and how it's using new features of the language to allow you to build applications in the browser. So one example of a new feature that was added in ECMAScript 2015 is the string template. Instead of concatenating strings, I can now poke things into a string literal using $ and curly braces. So I want to build a URL that includes a category and an ID. And notice these are not single quotes. These are not double quotes. That's the backtick that you use to build a string template. And what's even more fascinating about string templates is there's the concept of a tagged template. So I want to call your attention to this line of code almost at the very bottom, where I say test and a string template here, because you can place an identifier in front of your string template, and that identifier is going to be a function that the JavaScript runtime will call, and it will pass in specific arguments. What the JavaScript runtime will do is take all the pieces of literal text that are in this template, pass that in as the first parameter that will be an array, and so I can write asserts in here that says, yes, the first literal, I would expect it to be hello, comma, space, because that's the first part of the template down here. And then all of the values that I use by picking up variables and poking them into that string, they'll be passed as a second parameter here. This is the REST parameter syntax in ECMAScript 2015, where you just preface things with ... And that gives you a variable number of arguments that can be passed into the function. So instead of using the implicit arguments variable, you can just throw as many parameters at this function as you want. They'll all just be wrapped up into a true array, and in this case, passed as values. That will contain my values. And the interesting thing about tag templates is that you can interpret this information any way you want. So some people might want to write some sort of domain-specific language inside of a tagged template and produce some sort of output that doesn't necessarily have to be a string. Down here, I could return anything. I could return the actual something that I tried to compute from that tag template, but I could also return the number 42. I could return anything. In the future, tag templates are going to be interesting because you can imagine built-in primitives here or tags that are provided for me that will do things like safe HTML encoding. So I could build a string that my intention is to take that string and put it in the browser, but I want to make sure that I avoid cross-site scripting attacks. So maybe if the browser can help me out by exposing an API and I can build HTML and have a little tag here called safe HTML or something like that, that would be wonderful. You can imagine using this for localization, all sorts of interesting things. Classes, obviously, are a big deal in ECMAScript 2015. Not everybody is a fan of classes. Some people are quite happy with JavaScript being a functional language. And certainly there's a move towards immutable data and objects don't always play well together. But if you look at some of the frameworks that are coming out in the future, notably frameworks like Angular 2 and Aurelia, they do plan on using classes and building components, and you'll instantiate objects. And classes in this version of JavaScript, you can have a single constructor. So when someone applies the new keyword to this employee symbol, that will instantiate an instance of this class. Every object that you instantiate here will have a do-work method. It'll have a readable and writable property called name. So get and set, those were actually introduced in ECMAScript version 5, but nobody really used them because not all browsers supported them. But moving forward, I can see them being quite useful with classes. And even worse, there's inheritance. If you don't like classes, you certainly don't like inheritance, but it is possible for me to write a class that extends some other class, and I can use the super keyword to invoke a method in my base class by the same name, just by invoking super and passing along any parameters I want. So now every employee would have a name and a title, because the person will inherit that name property in that name field from person. So again, just running through a few features, then we'll dive into a framework. Arrow functions, I think, are quite interesting. If you're a C# developer, you've come to love Lambda expressions, and they work almost syntactically equivalent to the way they work in C#. So if I want to write a function that takes two parameters, I have to use parentheses and say, I take x and y, and that goes to an expression that returns x plus y. And if I want to write more code than that, I can use curly braces to denote the block of my arrow function, and I can use an explicit return statement to say I want to return something. If I only use one parameter, I don't have to apply the parentheses around it. I could just say x goes to x times x, and a function that takes no parameters, I can just use empty parentheses. And this is really nice. When you start looking at next generation frameworks and the way they write their code, obviously in JavaScript, we're always writing functions, callback functions, or functions that we pass to other functions, or functions that we pass to promises. And it's always been unfortunate that JavaScript is such a functional language, but that keyword function is an 8 characters of text that I have to type all over the place. Arrow functions really clean a lot of things up. Something else that I think is interesting if you're building frameworks and you're looking for encapsulation, what happens if you want to build some sort of object like a classroom that's going to encapsulate a collection of students inside? But now someone else needs access to those students because they want to do data binding, or they want to collect them together and put them into an HTTP message and send them to the web server. How can I give them those students? Traditionally in JavaScript, I would either have to give them a reference to that array, which means they might push something into it or pop something off of it, which really isn't what I want. Or I make a copy of that array and give them a copy, which is expensive. ES 2015 has the concept of iterators and iterables. So this is low-level iterator code, by the way. I have an array, 1, 2, 3, and 4. If I go to the .values method, that will give me back an iterator. And an iterator is just an object that has a next method. So if you're a C# developer, this is very similar to the relationship between IEnumerable and IEnumerator. I'm going to get back an iterator. I'm going to ask it to go to the next thing. Every object that I get back from next will have a done property. That's true or false. Have I reached the end of the collection or not? It will have a value that contains the actual value that I pull out of here. And again, this is the low-level code. I'll show you an easier way to write this in just a bit. But the beauty of having iterables and iterators in a language is, it's hard to say just how exciting this can be. It doesn't look like very exciting code, but it's very exciting. Just think about how you can encapsulate different sources of data behind iterables and iterators. I don't know now if that data is coming from an array or some fancier data structure. ECMAScript 2015 also now has maps and sets. But here's an easier way to write that code. The for of statement. That will walk up to numbers, ask it for its iterator, and then use that iterator to walk through the values that are in the array. So every n that I pull out of numbers will be one of those numbers, 1, 2, 3, or 4. Unlike the for in statement, which would give you the available indexes in an object. But another interesting question to ask about this piece of code is how does this for of statement, how does it know how to pull out the iterator from numbers? And to answer that, just have to take a quick look at something else in the new version of JavaScript, symbol. A symbol, when you invoke this function, you're creating a new value that is both unique and immutable. So even if I create two symbols with the same friendly text inside of them, I'm getting back two symbols that do not compare equal. And the interesting thing about a symbol is I can use a symbol as a key into an object. So when I create a symbol, I can use a symbol to put something into an object. And the only way to get that thing out of the object is to have access to a symbol, the symbol that I use to put it in there. Because it's a unique value, no one else will know it. And this makes extensibility very easy. So here's an example of creating a person object. And I'm going to add this first name property using a symbol. Again, the only way to get that out of there is to use the symbol to get that first name out. And this is how iterators were added. There is what is known as a well-known symbol, which is symbol.iterator, which you can use to walk up to an object and index into it. And if that object exposes something from symbol.iterator, that should be the function that you can invoke to get an iterator out. So instead of designing the language where you had to have some method name to implement an iterator, like getIterator, which might break existing code because someone has already written code that has a getIterator method and object somewhere, the specification committee decided to come up with this idea of symbols, and symbol.iterator would be a way to index into an object and pull out an iterator. So I should be able to walk up to a string and get an iterator. An array has an iterator. A number like 45, it would not have an iterator. And that means, going back to the original problem of how do I expose my students, this would be the syntax to add that iterator method to my class and allow people to use a for-of loop to go through the classroom and pull out each individual student without having access to the array. So it's a nice bit of encapsulation. Yeah, ignore that one for now. We also have generators in this version of ECMAScript. So notice the asterisk after the function keyword. This allows me to use the yield keyword. And if you're a C# developer, it behaves just like you would expect. So it's lazy evaluation. I only have to yield the values that someone is asking for with an iterator. So this generator function produces an iterator, so I can use a for-of loop over that function and pull out each number. And all the interesting things that you can do with language integrated query and C#, the way you can lazily evaluate some source of objects and do things like where and filter and skip and take in a lazy fashion. You can do that in JavaScript now too, which is a much more sophisticated way than just writing a for loop that always has to iterate immediately through a collection. This is another way to give my classroom an iterator using a yield statement. And now I could even, traverse students backwards or forwards. I could do whatever I want. Async code, also traditionally a problem in JavaScript. The community has realized that async code is a problem. This is the pyramid of doom that people traditionally talk about, where you have a callback that does something async, so it needs another callback inside of it, and so forth. The community put together a specification for promises, and the ECMAScript committee took that specification and built on it and said, yes, we like promises. This is a function calculate that doesn't immediately return a result. Instead, it will, after some period of time, produce a result, but what it will return immediately is a promise object. And this is one syntax you can use. You can instantiate a promise, take in a resolve parameter and a reject parameter. Those are functions, so if you invoke resolve, you're saying, yes, we completed the work successfully. Here's the answer that you're looking for. In this case, it's the number 96. If I invoke the reject, that's a way of saying, no, this promise failed. And down here, when I invoke calculate, the consumer side of a promise has an API, so I can do things like promise.then and pass in a function, what to invoke if that was successful, and what to invoke if there was an error. And the beautiful thing about promises is the way they compose together, or the way they flatten out asynchronous code by virtue of the fact that you can chain them together. So this is an example of saying, I want to invoke calculate that will return to me a value in the future, that promises to give me a value in the future. So if it works, I want to take the result that I get from the original calculate and pass it to calculate again. This line of code is just an example that every time you invoke then, it doesn't matter what you do inside of then, it will always return another promise. So that's just a little arrow function that says, take the incoming result and just return result plus 1, but that will get wrapped in a promise that I can use another .then and pass that into calculate once again, and the end result will be that I'll go from 1 to 5 with that little bit of code. Fascinating, I hear you say. Well, to me, actually, the biggest change coming up in JavaScript is the fact that we're actually going to have modules. So When we write code for the browser, we do all sorts of horrible syntactic things to make sure that we don't put variables into global scope. So this is your traditional immediately invoked function expression that wraps pretty much every bit of browser code that we write today just to give us a scope where we can declare variables and they don't escape into the global scope. ECMAScript 2015 has a module syntax, which we'll look at in just a bit. There's other ways to solve that problem. The Node.js community put out a specification called CommonJS. Node.js has the advantage of being something that has access to a really quick file system. So this CommonJS specification for modules, where you can say, I want to require this component and name some module and bring it in, that relied on the fact that Node could scan through the file system and quickly look that up. The community adopted that specification to work in the browser using asynchronous module definitions, where now I can require some module, but then I have to provide a callback function for when that module is actually resolved and brought back some symbol that I can use successfully. And if you take a dependency on require.js, you could be programming in the browser with modules today, but I just haven't seen a lot of that over the years, and there's certainly very few frameworks that have taken a hard dependency on require.js, just because not everyone wanted to deal with modules this early in life. And that meant libraries like jQuery and Angular and Lodash, they pretty much all relied on exposing some sort of global symbol like an underscore or a $sign or the word Angular that was the gateway to all the functionality, or it was the namespace where you could access everything else. Modules in ECMAScript 6 completely changed this. Now when you write a JavaScript file, you don't think of it as a file anymore. If you're going to properly be working with ECMAScript 6 and using some tools, which I'll discuss here in just a bit. Now when you write a .js file, you think of it as a module, and you have module scope. And there's no reason to surround things with an IFI, because even if I declare a variable on the first line of code inside of that module, it's not going to escape into the global namespace. It's going to be local to that module. And only things that I explicitly export will be things that get exposed from my module, and other people can have access to that symbol if they import it properly. And an example would be, I want to import person from this file. It's really a module. Don't have to use the .js extension. This dramatically changes how you build frameworks, because now frameworks don't have to expose the single global. They can just write modules and expose certain things, and you import what you need. This would be an example of exporting multiple things. So I want to export both the person class and this worker function, or the work function, but I'll alias it as worker. Now just a quick note about what works today. Obviously none of this just works inside of a browser yet, for two reasons. One is not all browsers implement all of the ES 2015 features yet, but that's okay. If you go to this web page, this actually is a compatibility matrix of what tools and what browsers and what environments support which feature of ES6. And you'll notice there's still quite a bit of red there, but all we really care about is that there are tools, compilers, transpilers, that can take my ECMAScript 6 code and compile it or transform it into code that can work in today's browsers. And that's what a lot of these frameworks are doing today, and have been doing for over a year, actually. That takes care of one problem. Babel is, I think, the most popular JavaScript compiler these days. It's a tool that plugs into Grunt, plugs into Gulp, plugs into other tools, and you just feed it source code, and it spits out the ES5 source code that you want. You could do the same thing with TypeScript, by the way. You can even use it directly in a browser. So you can load up the Babel compiler and the Babel runtime, those scripts, into a browser, and then be feeding ECMAScript 6 code into the browser, and it will compile it on the fly. There's also polyfills that you might need if you want to take advantage of some of the new features of ECMAScript 2015. One popular polyfill is core.js, because not all of the new features of ECMAScript 2015 are syntax features. Some features are new data structures, like there's a map and a set. There's new methods on the array. There's new methods on string. Those are the kind of features that core.js can supply for you. Also, Babel will do that. Babel has its own runtime that you can plop into the browser, and it will take care of polyfilling anything that's needed. And then there's modules. So the ECMAScript 2015 standard specifies what the module syntax should look like in JavaScript, but we still haven't quite cleared up what the runtime behavior should be and what the browser API should be. So that's why if you want to work with modules, you'll need a tool like Webpack or a tool like JSPM, which I'll show you real quickly. And these are tools that can work with almost any type of module. If you write common JS modules or AMD modules or ECMAScript 6 modules, these tools can pick up those files and analyze dependencies and package things into scripts so that you can just put everything that you need into the browser as one file. Or maybe two files. Maybe you package your shell module into one script and get that into the browser real quickly. And as the user navigates through the application, you have the ability with tools like Webpack to package up your JavaScript so that some things get loaded later, lazy loading. An example framework that does a lot of this stuff is a framework called Aurelia. So let me just use the last couple minutes here to talk about Aurelia. Anyone using Aurelia? Tried it out? Looked at it? Yeah, it's a really fantastic framework. I'm going to skip through a few slides here and just let you know that to get started with Aurelia, you'll need to install Node.js, because all of the best JavaScript tools these days are written for Node.js, and all of the transpilers and compilers and module bundling tools, they all run under Node. You don't need Node in production, but you'll definitely need it during development time. One tool that Aurelia relies on, it's not required, but it's something that Aurelia uses, is a tool called JSPM. Its tagline is that it's a package manager for the browser, which means it's a lot like NuGet, it's a lot like Bower, it's a lot like Gems. I can tell JSPM that I want to install Aurelia, or install jQuery, or install Bootstrap, and it'll go out and fetch all the files that are needed for those frameworks, put them on my file system. But it goes further than that. It's not just a package manager to me, because it also provides a runtime that I can use to load those things up properly. It's a runtime that understands modules, understands ECMAScript 2015 modules, understands how to transpile things, and it also maintains a configuration file for me so that I don't have to describe all the dependencies I have and all the modules and how they interrelate. And it has things like bundling features, so I can tell JSPM I want to bundle my whole application together, and it can produce a single JavaScript file that I ship down to the browser, even though my source code is in 200 or 250 source code files. Just show you a quick example of what it looks like. Let's flip over to here. This is a running sample Aurelia application that you can get off GitHub. And before we go into the code, I'll just show you what it does. It has two-way data binding. It also has the concept of routing, so I can have different links go to different components that are inside of my application and keep them nice and decoupled. It also has the concept of activation life cycles for the different screens. So here I'm on a certain page where I'm editing a person's name, and I haven't committed that work. So there is a method that automatically gets invoked by the router on a model to say, is it okay if we navigate away from this now? And I can say, no, it's not, because the person hasn't finished this. And you could come up with a better UI than an alert box, but I do want to leave. It also has this nice compositional router where you can have routers inside of routers, and it's just very easy to use. And if I use the back and forward buttons now, it remembers all that navigation I just did. And here's what the code looks like. Let me flip over into this file. So what does my application look like? It's a class that I export, and that Aurelia will automatically import because it'll go out looking for something called app.js by default, or I can specify it also. This is where I'm going to configure the router to say, this URL maps to this module. So if the user goes to /users, I want you to load up this module. And Aurelia will just go out and import the class that is exported from here and instantiate it, and then I can perform data binding against the fields that are inside. And I'm importing some things from the Aurelia framework, including, you might be wondering about this syntax. This syntax is actually from the next version of JavaScript, the version 7 or the 2016 specification that they're working on. It's a lot like an annotation or an attribute, except it's a little more powerful than an attribute in something like .NET because it actually can do a runtime modification of the symbol that it's attached to. But this is what the new frameworks will look like, and it's just an amazing difference to walk into an application now, building it with Aurelia, and actually have some proper encapsulation and be able to export things and import things and not worry about going through some global symbol and registering things through something like Angular all the time. Anyway, that pretty much brings me to the end of my time. So let me accelerate here for just a second. Because I knew I wasn't going to get through all this, but if you do want to check out Aurelia, now I went too fast. Just bear with me 1 minute. Am I preventing you from getting lunch? Is that what I'm doing? The beta for Aurelia is almost here. It's like days away at this point. And if you go to aurelia.io, you can see more about this framework. Angular 2 would be another framework that uses this new syntax, so you could check that out too. And if you have any questions, feel free to email me. Thanks for coming.